Okay, so this video is going to be about upper bounds. For Ind3. Okay, right. So let me try and get to a spoiler here. So the spoilers are the following. So for so do I want the product version? I guess I'm not going to do the product version. So let omega subset of K1 tensor tensor Km so be some subset. Okay, so these Ki's over QP are finite extensions. We're going to take A and Km with p-adic absolute value less than 1. Okay, and then we have the following inequality. Then omega Ind3 of A is going to be contained in a to the n, the orbit of omega union the tensor product for I is equal to 1 up to m of log of O Ki cross, like so. Okay, so this is the result that we want to prove. Okay. Okay, so where does this begin? So this begins with the product version. So the strategy is it's just a computation. So we compute what ind of so the collection of indeterminacies of what this thing is. Okay, and then we apply this to get the upper bound in the tensor product case. And so there's a couple ways you can actually chop this up. A couple ways that I think that this is not tight. You know what I'm doing here is not. There's actually a couple other definitions of Ind3 you could have given, but this isn't the tightest thing that you could do. Anyway, so let's give some definitions. So notation for what we're going to do. So we're going to let log, we'll call it log bar. So this is going to be defined to be equal to the thing that you get from the free group, where if you take log of K1 cross Km. So that's the log on each of the components, like we defined before. And this is going to be from this free group here to this free group here. Okay, so okay, and then we're going to use this notation. So this is going to be the map induced by multiplication by A. Okay, so okay, so here's our lemma. Right, it says that the first thing that it says is that that this indeterminacy, the indeterminacies here, so these are generated by, let's do it like this, psi A log bar here. So it's generated by these things. So this is the clean closure. So this star denotes the clean closure, Kleene. So this is all words generated by these symbols. Okay, and then the second thing that we're going to show is that okay, given a subset here of the free group. So for these we have that omega tilde of Ind3 of A. So this is going to be, well, of course this is a consequence of this. I don't even know why I'm saying this. Star of omega tilde here. Okay, so it's obvious that, so obviously 2 implies 1. Or sorry, 1 implies 2. Oh shit. 1 implies 2. Okay? So, okay. Let's do the proof. Okay, so let's let S be this, proof. Let S be this free, this indeterminacy diagram here. Okay, and so by definition, we were going to write out what it means. So the indeterminacy diagram of S is the union for j less than I. So it's all the indeterminacies. Ji ind S ji gj inverse. Okay, so that's what all the indeterminacies are. You go up and around. Okay, so now let W be in here. So ind S ji gj inverse for some j less than I. Okay, and then we need to show that this thing has the appropriate form. So we want to show So let's actually look at this. So so what do we have? So in here, so we have the monoid actions. So we have these. So let's look at this thing. So K1 cross Km, right? So we have these monoid actions here, and then what we're doing is we're applying log to these things. Okay, so these are, of course, appropriately shifted, right? Log bar. So, so here, okay, so this is the not free version, right? But I guess we wrote the free thing here. But okay, so this is I guess this is not log bar, but just like, okay, so this is just like ordinary log. Okay, but if we did free this, then it would be log bar. Okay, so what you can do, how do you get from one node to say another node, right? So what you do is you apply psi however many times you want, you go log, and then you apply psi however many times you want, then you go log. Okay, so here, so this tells us that this thing S ji is words built from this log pre, okay, and psi with exactly I minus j instances of log pre. Okay, that's how you get over. You only get over by doing a log pre. Okay, so so with GK, this is the Kummer map, the kth Kummer map. We get so our word looks like so Kummer of I, psi of ni. So I got my indices backwards here. This is log bar psi of ni minus 1, because the I is bigger than j. Okay, and then we have log bar dot dot dot. Okay, and then it ends with a log bar psi of nj Kummer j minus 1. Okay, so it's better to just write this out. So here, so the rules are, okay, so we'll write it like this. Okay, so here's j, here's I, and then we have the Kummer maps going down like this. Okay, and so the rules are that so that psi a Kummer is equal to Kummer psi a, and so let's see how we do this. So Kummer inverse, we can do Kummer I inverse. We have something like this. So the whole point is that it's equivariant, right? So you could do forward or backwards Kummer. The other rule is that so the other rule that we have is that log, the conjugation by log, so the conjugation by pre-log is, so if we do Kummer, let's do this, Kummer k inverse log pre Kummer, and let's delete that one. Kummer k plus 1, right? So this is just the usual log. Okay, so so this is so this will give us actual logs. Okay, and now we use this to change our word. So we're given a word. W is this thing, Kummer I psi ni log bar psi ni minus 1 log bar psi ni minus 2 dot dot dot. Okay, now I'll show you how we get down this thing. So we have another Kummer at the end. So here we get to move this around. Kummer I log bar. Okay? Now we're at the I minus first version. So we'll do Kummer I minus 1 inverse. Then we'll do Kummer I minus 1. So now we've done this. Psi ni minus 1 log bar psi ni minus 2 dot 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 dot. Okay, so here, so this is equal to psi ni, and now this is the pre-log, so we get an actual log here. Okay, and now we are relegated to doing Kummer I minus 1 psi ni minus 1 log bar psi ni minus 2 dot 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 dot. Okay, and then at the end of it we'll have a Kummer j inverse. So all of these have a Kummer j inverse at the end. Okay, and so by induction, the proposition holds. Because we reduced one, we're just doing on the number of logs occurring, number of logs appearing. Okay? Okay. Okay, so now let's prove our proof of our claim. So now the lemma that we wanted to prove was that ind, so for now we're doing the tensor product version. A and Km, absolute value of A is less than 1. Then omega Ind3 of A is a subset of, okay, so we take the orbit, we take omega, we union it with this tensor product, log of OKI cross, like so. All right, that's what we want to do. So proof. Now we just apply our definitions. So for omega tilde, so we'll actually do the version for the free group here. So we have that omega tilde, so we write down the definition, omega tilde Ind3 of A. So this is by the lemma. How do we write this? We wrote it as this clean closure operation rather than a spanning operation. So it's this closure of this thing of times omega tilde. Okay, and so inside of here, right? Well, I guess, and not inside, but we have the inside of here we have all the elements that look like psi a n1 log bar psi a n2 dot dot dot. I guess log bar dot 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 psi let's say log bar psi a n r plus 1. Okay, so we have a bunch of these things. That's okay. Sorry. We're writing this as an element because I was going to do it with an x. Okay, so for x is an element of this. So this thing here, this thing is equal to, well, it's just equal to psi a n1 of y. Okay, for y. So where's y? Y is an element of omega tilde, or y is an element of log bar of omega tilde. Okay, so this tells us that it's going to be some multiple of something in here and something in here. Okay, so this tells us that omega tilde Ind3 of A is contained in, well, some multiple of omega tilde union, this thing, so the product of these logarithms. So free product I is equal to 1 up to m of log of OKI cross, like so. Sorry if I'm covering my mouth. It's kind of a bad habit when you're making videos. Okay, so we have this. Fantastic. All right. So now, what about for tensor products? All right. So the quotient map. So the quotient map is A n equivariant. Okay, so this proves that we have that this is contained in the general case. Log OKI cross. Boom. That's done. All right, so now we have an upper bound for we have a good definition of Ind3, and we have an upper bound for Ind3. If you were patient to go through the whole thing, thanks for watching. All right. Maybe see you at a conference or something.